Algebra 1, Section 6.5, point slope form. Again, we're going out of order here. We did 6.4 in the last video. This is 6.5. We will back up after this video and pick up 6.2 and 6.3. But I want you to see the value in point slope form today before we get to the old comfortable one, right? So point slope form, y minus y1 equals m parenthesis x minus x1. You need to know that x1 comma y1 is a point on the line. x1 comma y1 is a point on the line. And then you also ought to know that m is the slope, and maybe you knew that already. And just looking forward, one more video, m here, same thing. It's going to be the slope. So they use the letter m for both of those. Not sure why they use the letter m, but that's what we always have used. So that's the slope. These are the points. The other components would be x and y. And do you notice that in standard form you have an x and a y, and in slope-intercept form you have an x and a y? And when we get into quadratics, you're going to have an x and a y. It's because there's always an input and an output. It's because there's always an independent variable and a dependent variable. There's always a domain and range, which stand for the possible inputs and the possible outputs. Domain is inputs, range is outputs. So when we ask you for an equation, there ought to always be an x and a y. And I bring that up specifically with point slope form because the common mistake would be that if you're given a point like this, to plug it in for x and y, when what you really want to do is plug it in for x1, y1, so that you're preserving x and y to be the variables that you need in the equation that you're trying to provide. X and y should be in your final answer when we ask for an equation. Okay, so I neglected to mention in the last video that you do need to memorize these. Make sure you have standard form memorized by the time the quiz and test rolls around. Same thing with point slope form. You ought to have this memorized. The slope formula from 6.1 ought to be in memory. And when we get to slope-intercept form, we'll have four things really at this point that have been committed to memory. The slope formula and these three forms that you see right here on the screen, these three forms of lines. Okay, so let's talk about point slope and how this works by doing a few examples. Here you have an equation that is in point slope form, and they ask us to graph the equation. Now I'm going to roll to the graph, but let's just talk about what you see here. First of all, the slope is this number right here. Okay, and then the other component, and the reason why this is called point slope form is because when you're given a point and a slope, you can write the equation, or vice versa from that. If you're given the equation, you can take the slope and a point right out of it. Point slope form. I can see a point that's here right now, and it is 1, 2. Now, did you notice that in point slope form that we had written on the other screen there, the natural state of these things right here is negative, okay? So when I see a minus here and a minus here, I know that these numbers are positive, right? Y minus y1, y minus 2, 2 is a positive number. The point that I'm going for is going to be 1 comma 2. Not, the y value is 2, the x value is 1. 1 comma 2. This is a positive number here, okay? If you had seen a plus here, you should interpret that as x minus a negative 1, okay? That would mean that the number is negative. But we're talking about a point here that is 1 comma 2. So that's everything we need. We can plot the point 1, 2. We can plot other points from that using the slope of 1/3, and that would look like this. Here's the point 1, 2. The slope of 1/3 means rise over run, up 1, right 3. Up 1, right 3. You could also go down 1, left 3 and get several nice points. I do not like how they kind of zoom in on the graph here. Just use my graph paper. Again, you'll need graph paper for this lesson, so hopefully I've passed you some out, or you just have kept a few extra sheets in your folder for this moment. It's always in the back corner of my room. And just use the graph paper that I give you that goes from -10 to 10, -10 to 10, and draw a longer line than they're going to show here. Anyway, there's the line. And we graph that out of point slope form because they gave us a point, we can plot it. They gave us the slope, we can go off that point. Okay, you probably want to make this mistake, but it's worth mentioning. You go from the point that you plotted, not the origin, but you plotted a point, and then from there you go rise over run, up 1, right 3, up 1, right 3. Next example, write the equation of the line with the slope of -2 that passes through the point 3, -3. I hate when they do that. Let's just change this so that's a different number. Let's go with -5. 3, -5. And we're going to use y minus y1 equals m x minus x1. I would suppose that by the time you've done the homework assignment, you pretty much are going to have this memorized anyway, but do make sure that you do have it memorized for any assessment. And -2, the slope, is going to go in here for m. This is the x value, going to go in here for x1. The -5 is the y value, going to go in for y1. Now keep that in mind that this is negative and this is negative, so y minus -5, change that to plus, equals the slope -2, x minus the number 3. There's point slope form. Notice that it doesn't say what form to write it in. It says write an equation of the line with the slope -2 that passes through the point 3, -5. Done. Okay, so I'm going to use point slope form and I'm going to be done. The book's answer documents are sometimes inconsistent when it comes to this, so you may see something in slope intercept form, and yes, you would have to switch this over to slope intercept form in order to check your answer. Let's just do that real quick. All you'd have to do is distribute the -2 like so, and then subtract 5. This would be in points in slope intercept form. You don't need to do that unless you need to check an answer that's not in the same form as yours. I say do less work. They said write an equation. I did. I wrote an equation. All right, next one. Write the equation of the line in point slope form and in slope intercept form. Okay, so we're not going to do this part yet because that's tomorrow's lesson or the next video's lesson, but we will write it in point slope form. Notice that the slope, as I look from one point to the next, the slope would be down 1, right 3. The slope, the m value, is -1/3. Be careful to note that it's going downhill, so that's a negative number. Down 1, right 3. It's -1/3. Now look, watch this. I could go y minus 4 equals -1/3, just like we did it on a previous problem. X minus -1. I could just the same go y minus 3 equals -1/3, x minus 2. And you might look at those and think those look different, but I'm going to prove to you right now that they actually are the same. And I guess in doing so, I'm really going to do the second part of this, although the requirement of switching things to slope-intercept form will come later for you in the curriculum. But just to prove that these two are the same equation, allow me to distribute the -1/3 here. And then if you would add 4 to both sides, as in add 4, so you get y by itself here, and then add 4 to this number on the right side, you'll have -1/3 x. Adding 4 would give you +3 2/3, which would be +11/3 or 3.6 repetend, any of those. Distributing the 1/3 here, the -1/3 here, this would be 2/3, +2/3. Negative times a negative is positive. 1/3 times 2 is 2/3. And then if I added 3 to both sides, guess what? That's going to be 3 2/3. Y equals -1/3 x plus 3 2/3. So they're the same thing. Okay. You didn't need to draw to write both of them. One or the other would work. And these are both in point slope form. Okay. But really, again, just in proving to you what I wanted to prove to you there, slope intercept form is what you got here. And the same thing there. Okay. All right, I'm going to roll ahead to example 5, and then we'll come back and do example 4. It says, is the relationship shown by the data linear? If so, model the data with an equation. So what you would need to do to show that this is linear would be to be able to calculate a slope and see if they actually lie on the same line. And you'll see that they do this in an interesting way. They're subtracting, okay, 1 minus 0, I guess the other way around, 0 minus 1, -1 minus 0, -2 minus -1. Doing the same thing over here and then dividing. Why are they doing that? Well, because the slope formula is this. And if all these points lie on the same line, then you're going to get the same slope. And the difference here in the y's would be -1, as if they just subtracted y2 minus y1, -2 minus 1. And then the difference here is also -1, so they're going to get a slope of 1. Now, if you do that 3 times, they get, let me just clear off what I have there. They get one of them that's 1. They get this one that also turns out to be 1. This one does not come out to 1. See the not equal to? It's not 1. I almost think at some point it might just be easier to plot points. -2 would be here. -1, -1, 1, 0 over here. Is that going to be on the same line as these two? No. Okay. So the question is the relationship shown by the data linear? If so, model with the equation. We can't do that second part because the answer to this question is no. Okay. Now with that in mind, let's just roll backwards to the previous example, which is the same question. And just for sake of time, you can check this if you want to. You can calculate a slope with these 2 points, and then with these 2 points, and then with these 2 points. Use your slope formula from section 6.1, and you will find that they are the same number. They come out to the slope of 2. Each time you get a slope of 2. This then shows that they are on the same line. Side note, they're on the same line not just because they have the same slope, but they're also points on the line, right? There are plenty of lines that would have a slope of 2, but only lines that have a slope of 2 and these unique points, 3, 6, 2, 4, -1, -2, -3, -6, are going to lie on the same line when we use those points in the slope formula. Okay? So if you believe that, I hope my explanation was okay there. I'm trying to keep the video short. Then we can go ahead and go y minus y1 equals mx minus x1, plugging the slope of 2 in here, and then any of these points. And I won't take the same tack as I did 2 problems ago to show you that they're the same. You can test that on your own time if you want to. Just pick a point and plug it in. I'll just pick the first one. 3, I'll put it right here for x1. 6, I'll put it right here for y1, which means you have y minus 6 equals 2 times x minus 3. But really, you could have used any of the other ordered pairs here just the same. Use the last one, you're going to have y plus 6 equals 2 times x plus 3. Minus negative means plus. Okay? Thanks for watching.